Welcome to Module 1, the sound. In this module, we will explore the basic of sound properties from the physical point of view. Sound plays a vital role in our understanding of the physical world and communication. In this lecture, we will break down its properties and perception, ensuring a solid foundation for our future discussion on this fascinating topic. I would like now to let you watch the following video. In the video, there is something wrong. Maybe you will discover, and there is something wrong from the physical point of view. The problem in this video is that we hear the sound of the spaceship in the space. Well, this is a poetic license that has been adopted since foundation of cinema industry to make movies more involving. Indeed, sound cannot propagate in space, since in space there is not the presence of air particles. Those who had the chance to watch the movie Interstellar might have noticed that a silent explosion of a spaceship in a certain scene. Hence, the sound, in order to be heard, needs to be able to propagate. Sound propagates through a transmissive medium. It always needs a transmissive medium to propagate. Sound, as defined by Treccani, a dictionary, Italian dictionary, is the cause of acoustic sensation originating from vibrations in a medium, like air. These vibrations propagate to our ears, creating auditory experience. Note that sound cannot exist in vacuum, so in the space. It needs a transmissive medium such air, water, or even solid. This foundational concept highlights the physical nature of sound as well as its connection to our sensory perception. Every sound begins at the source, travels through a medium, and it is captured by a receiver, either our auditory system or an analysis system like the microphone. We call the journey from source to receiver as propagation. This journey can be split into two parts. First, the physical propagation, which involves sound as a physical phenomenon. And the second, its interpretation by our brain, which gives rise to acoustic perception, which is the acoustic sensation. Our brain is phenomenal. For instance, think of a guitar string vibrating. The physical waves reach our ears and are interpreted as music, or we might provide an emotional interpretation of it. Again, our brain is phenomenal. Most specifically, when analyzing sound, we can take two distinct approaches, the acoustic one and the psychoacoustic one. The acoustic perspective focuses on sound as a physical wave. Psychoacoustics, on the other hand, deals into how our auditory system and brains perceives these waves. The acoustic approach is governed by measurable laws of physics. Hence, it describes sound from an objective point of view. In psychoacoustic, our perception comes into play. As we will see in the next module, sound, in fact, is picked up by our auditory apparatus, translated into electrical stimuli, sent then to the brain and interpreted by it. Our perception is subjective by nature, since it includes personal and subjective factors like individual hearing ability, cultural context, and even emotional state. For example, two people might perceive the same sound differently, depending on their mood or cultural background. This makes us unique listener. Psychoacoustics quality are hence difficult to measure. To understand the difference between acoustics and psychoacoustics, let's examine their respective quantities. Physical quantities like sound intensity, frequency, and spectrum are objective and measurable. Psychophysical quantities, such as the sound sensation, the pitch, and the timbro, are subjective. So let's provide some definitions. The sound intensity is the ratio of the power carried by the wave to the surface which it affects. Quality distinguishes weak from loud sounds. The frequency is the number of oscillations per second of a sound wave. The sound spectrum, which is the diagram representing sound pressure versus frequency. The sound sensation, which is the measurement of perception of the intensity of the sound. Sound pitch, which is the quality that makes it possible to distinguish whether a sound is high or low and depends on the frequency of the sound waves that generated it. And timbro, which is the quality that allows two sounds with equal intensity and pitch to be distinguished. Thus, timbro represents that attribute of auditory sensation that enables the listener to identify the sound source, making it distinguishable from any other. This interplay of physical and perceptual attribute is the key to understanding sound. Physical and psychophysical quantities often interact in non-linear ways. For instance, a Fletcher experiment demonstrated that pitch perception changes with intensity. Low frequencies sound lower pitch at higher volume, while on the other side, high frequencies sound higher pitch. Such findings reveal the complex relationship between sound's physical properties and our subjective experience. This helps explain phenomena like why loud music can sometimes feel more harmonious. Finally, let's summarize the components involved in sound generation, transmission, and perception. These include the source, the medium, analog or digital, the auditory system, and the brain, finally. Each component modifies the sound in a unique way. For instance, a singer's voice, source, travels through the ear, which is the medium, and before to be processed by our ears and brain. Factors like culture and intelligence shape how we interpret what we hear. In summary, we have explored the fundamentals of sound from its physical properties to its perception. This duality between acoustics and psychoacoustics reveals how sound is both a measurable phenomenon and a deeply personal experience. In our next sessions, we will build on this foundation to explore sound's applications in technology and media. Thank you for your attention.